Welcome back. In this video, I'm going to explain how sprinkler systems work and how they're tied in to the fire alarm panel. So the most basic type of sprinkler system is called a wet system. And what that means is that the system is always filled up with water. There's different types of sprinkler systems for different applications in buildings, and I'll explain some of those in the future. But for right now, it's going to be a wet system. So that means like I said, there's always water sitting at each one of these sprinkler heads. And the way these things work, it's not like the movies where you pull a pull station or a smoke detector goes off and the whole sprinkler system activates. You probably already know that, but the way these work is each one of these is basically a plug. I drew a sprinkler head ahead of time, so each one of these works basically like a little plug, and it's filled with some sort of fusible element to it that is holding back the water. So in this diagram, this little red tube here is glass. The most common sprinkler heads have glass right here, and it's filled with some sort of chemical that expands at a certain temperature. So I think the most common temperature is 165 degrees, but they make different ones for different applications. So what happened is there's water, in the whole system, at each sprinkler head. It's held back by this little glass, which will break, and this chemical inside here is going to expand. So if it gets hot enough, this will break, and the water will be released. The little spiky thing down here is a deflector, so the water's gonna hit that and then just go every which way and put out the fire. So I think it's a pretty straightforward idea. I drew this little fire ahead of time. So in this building, in this school, which is the same school we've been using in all of our examples so far, if the fire started in this center wing here and it got to this sprinkler head up here, and let's say it was 165 degrees at that head would burst, the glass would break. Or there's other types too that use like a fusible metal that holds it back, but it's the same idea. Once that gets hot enough, it'll break or melt or whatever, and the water will be released just at that one. And then if it got hot enough at the one next to it, that one would break as well, but it's not like the whole system's going to go off. So let's look a little bit more closely at some of the details of a sprinkler system, because that was a very basic idea. The nature of sprinkler systems is a little bit different than regular water pipes, because they basically, once the system fills up, the water just sits there and it rarely gets used, hopefully, if you don't have a fire, except for when you do testing and stuff like that. So the water gets really gross. It's all, if you turn on a sprinkler system, there's this nasty brown water that smells, and you need to separate that from city water, because you don't want that nasty water to mix with the water you drink. So the way it works in buildings is, let's fill the system up. The way it works in buildings is the water will come in from the city, and then at some point it'll separate. And the domestic water's over here. That's the water you drink and shower with and all that. And then there's what's called a backflow preventer, which is basically a check valve. So this purple gate here is hinged, so it would allow water to flow this way. The gate would just lift up, but we won't allow it to flow back, hence the name backflow preventer. If you remember when we did diodes, when I explained diodes, I used that same concept of a check valve. This was the picture that we used when we did diodes. And then the idea here is that current can flow. The diode allows current to flow in this direction, the light bulb's on, but if this were reversed, negative and positive, current would not be able to flow in the opposite direction. And this works the same way with water. I think that's an easy enough idea. So, what do we have to worry about? What does this have to do with the fire alarm system? Well, there's any type of water system, you need to have shutoff valves, right? And in your house, if somebody shut off your water, you'd know it, because you use water every day. You go to turn on the water, you got no water, you're like, oh, there's a problem. We know we need to fix this. Well, with a sprinkler system, would you really know if someone shut off one of these valves right here? There's always at least two valves. There's always one on each side of the backflow preventer, so that when you have to replace it or whatever, you can shut off the water. Well, if somebody had shut this off and this system was not full, there was no water in the system, or even if there were water in it, once a sprinkler head broke, if one of these valves was shut, you'd only have the water available in the system, and once that was gone, then, well, first of all, there'd be no pressure. Second of all, you wouldn't have enough to put out the fire. So the idea is you have to know when someone's shutting off these valves. So I'm going to show you in the next few minutes how this is tied in. There's little devices that monitor these shut-off valves so that if one of them is activated, if this is shut, it's going to cause a condition on the fire alarm panel to let you know there's a problem. And then the other way it's tied in is if water's actually flowing, if there's a fire, once the system's filled up and all the sprinkler heads are in place, it's a sealed system, no water's flowing. That water's just sitting there. But if one of those heads burst and water started to flow, you need to know that as well. And they have a device that's called a water flow switch, which is just basically a paddle. Like this is my water flow switch right here on the left. And there's a little box where your electrical connections are hooked up, where it's hooked up to the fire alarm panel. And then inside the pipe, there's a paddle. And so when water starts flowing this way, it hits that paddle and pushes it up. And that triggers a switch. It doesn't trigger a switch immediately, just because differences in pressure, sometimes this paddle will move a little bit. So there's a delay switch, which is inherent in these. They actually call it a retard switch. And you could set the timer for that. I think it's got to be less than 90 seconds, if I'm not mistaken. But, usually it'll be about 30 to 45 seconds, somewhere in there, so that water would have to be flowing for that long before the contacts actually change states. And we're going to explain that a little bit more right now, actually. Well, actually, I guess we're not. We're going to explain that in a minute. This is the example of one of the most common types of valve tampers. Basically, all you need to know is that there's different types of valves, and there's different types of ways that we can monitor them. But the idea is, just like there's a set of contacts on there, just like there were alarm contacts and trouble contacts on our panel. They're called valve tamper switches. Are just a set of contacts that are going to change states when the valve closes. And depending on the type of valve, there's different ways that mechanically that happens. But the idea is pretty simple. This type of valve is an OS and Y. It's an outside stem and yoke. So the brown thing right here is the stem. And when you shut this valve, if you were to turn this wheel, this stem would start to go down. If it were closed, you could tell just by looking at it that this stem would be completely inside the red. I think that part is called the yoke. I might be wrong about that, but this thing is actually going to go down. So hopefully you can tell that I made this little groove right here. So that darker spot here is a groove in the valve, and the reason that's there is this valve tamper switch. Hold on one second. This valve tamper switch has a little lever on it. It's got a little arm that'll go, back and forth. And when it goes back and forth, it changes states of the contacts that are connected to it. So let me try to. I don't know if this is going to work. This thing's kind of hit or miss. Yeah, it's not going to work. I don't know why. That's frustrating. Anyway, so hopefully you can imagine this little arm would sit in this groove, and you calibrate the valve tamper. So that it's in a normal state. The contacts are in their normal state when it's positioned right in the groove here. And once you start to turn the valve, this goes, like I said, the stem goes down. So when the stem goes down, the valve's still going to stay in one spot, but now because it's got that little curve to it, so maybe the valve would be set right here in this curve, but as this starts to go down, it actually pushes that arm out, and it changes the state of this valve. So you'd have your fire alarm hooked up to the contacts that are internal on here. Maybe common and normally closed if you wanted to cause a trouble, and we'll talk about that in a little bit. And so that would change the state. You start to turn this, it's going to cause a condition on your fire alarm panel. Okay, so there's kind of a lot going on here. And actually, I'm looking at my timer. I think I'm going to stop that video there, and I'm going to pick up here in the next one. So I'll see you in the next video.